conditional on winning, right? How much you bid has no effect on what you pay. And conditional on losing, it doesn't affect anything, right? But you never want to change whether you win or not relative to how you would win based on your valuation. Why? Suppose you bid too low and somebody bids a price that's between your true valuation and what you bid, right? That's the only time when it's going to change the outcome, right? In that case, you could have won and paid what that person bid, which you would have been willing to pay. And so you're sad about that, right? On the other hand, imagine that you bid too high, and that's only going to cause a problem if someone bid between how much you value it and how much you bid. So in that case, you'll end up winning and paying a value that's more than it's worth to you, which clearly is not in your interest, right? So in either case, you don't want to either overbid or underbid because you can only change whether you win in cases where you wish you hadn't changed whether you won, right? And the reason is that only by changing the allocation is your payment affected. And when you change the allocation, you pay exactly what it costs to everyone else to do that, right? And therefore, you want to always report truthfully what you know about the situation, right? Now, this is sometimes used in what are called, yeah, go ahead.
Why isn't that necessarily true for regular auctions? What does that have to be?
So in a regular auction, right, I pay what I bid, right? And therefore, the amount that I pay is affected by what I bid, even contingent on me winning or losing. Well, it's contingent on me winning, right? So I would never want to bid my true valuation in like a normal auction, right? Because then I don't get any value, right? Because I always pay what I bid. So even given that I'm going to win, I could pay less if I bid less in a normal auction. And therefore, I'm going to always want to reduce my valuation below what it really is in a standard auction. Whereas that's not true in a second price auction. But it's contingent on me winning, I don't have any effect on how much I pay, right? Now, this method is sometimes used in what are called multi-unit package auctions, where you're bidding for, imagine that I could get, there's like 100 different things, different particular objects. And I could get this 6 of them or that 7 of them or whatever. And I could put in bids for all those packages, right? And then I would have to pay however much I changed the sum of everyone else's values by having submitted the bids that I did that changed what was allocated. You know what I mean? So that's the generalization of this basic principle. So like, an example of that would be, suppose that there are like 2 objects. And Chrissy and James bid a value for object A, and James bids a value for object B. If I now submit a bid for the package of the 2, then if I win, I should have to pay the sum of their 2 valuations, right? And more generally, however I change whatever the assignment is, I should have to pay the total change in other people's utility for that. And in fact, Paul Milgram is going to be talking tomorrow at 1:20, I believe, in the Booth School about exactly a way to implement the VCG in a very complicated combinatorial package auction setting. Yeah, go ahead, Eric.
So just to clarify, in the multi-unit auction, there's like several objects, and
yeah,
the bidders can submit bids for any combination.
Exactly.
Oh, okay, and then okay.
Exactly. But as Paul will discuss, that's often really infeasible. So often you have to simplify the way in which people submit what they're bidding for. This is sort of like we talked about with Eric's thing. In principle, in Eric's thing, you would have to submit yeah. But in reality, you have people report it in a simpler language usually. Like you have them like bid on a few packages and say their value for those or something like that. You know what I mean?
And so how does the VCG deal with if like someone bids for a package A and B and someone else bids for C versus like someone taking just A and someone taking just B and C? Does it just go with whatever?
It goes whatever maximizes the sum of the total values. And then people have to pay however they affected things. So if someone bids for A and C, and someone else bids for the total package, and another person bids for just B, then the person who bids for A and C has to pay sort of like the difference between the person who values the whole package minus the value that the person who just bid for B gets. Because if the person who gets A and C wins, then it reverts to a situation where he gets awarded and the person who gets B gets awarded, but not the guy who gets the whole thing.
Right, so he doesn't have to pay for the externality on the B person because...
He actually benefits from the externality on the B person in some sense.
Right.
Because a benefit is that the B person gets it rather than the package person. You see what I mean? So it's a whole complex combinatorial thing, and that's exactly what Paul's going to be talking about tomorrow. So if you're interested in that, he actually is designing one of these for the Federal Communications Commission right now, along with Jonathan Levin and Ilya Segal, and he's talking about what he's doing there. And I think Larry Ausubel is also part of that project. OK. So you can also use this for course selection in an artificial currency. You could have these package bidding things like we talked about before. Now, there are many proposals to use this, but it's very uncommon to use VCG in practice. So let me give you one example of a case when you could use VCG. So imagine that rather than having eminent domain, where someone comes in to buy a package of land, and the government just takes the land away and then pays some compensation to people, you could have people report into the system, here's how much my land is worth to me, and then the package bidder could report how much it's worth to get the whole parcel of land, right? And then you could run a VCG mechanism between them, right? Then you could have people, if someone were to bid high enough to stop the assembly from taking place, they'd have to pay the difference between the amount bid by the person who wants the whole thing and the sum of everyone else in the community's valuation, because that's how much harm they're causing, is the difference between the offer that was made and the sum of everyone else's values if they switch the outcome to being that we don't put the land together and give it to the person versus we do, right? That's one way you could run that. And in fact, you could run it that way for the spectrum stuff that Paul's working on, because what they're trying to do is get together groups of spectrum so that they can put together things to do WiMAX on it, so that Wi-Fi that spreads over a broad area. Okay. Now, Paul and Larry Ausubel wrote a paper a few years ago saying that the VCG mechanism was lovely in the sense that it's very elegant and it has these nice properties. It's sort of really cool, but lonely, and it's not really used in practice very much. And why, does anyone know why the VCG mechanism is so lonely? It relates to some of the stuff that Jim was saying before.
You have to promise to burn the money after you raise it.
Yeah.
There's no perverse incentive effects.
Yeah. That's right. So the money that you collect can't go back to anyone who's involved in the mechanism. And you could say, well, it goes back to the government. But the government provides services that potentially benefit the people involved. So that's not enough. You really have to destroy this money. And if you're destroying this money, it's not just money. You have to destroy the real resources that stand behind the money. Because if you just destroy the paper money, well, that's disinflation, which is like benefits everyone, right? And so, so this is really not a very plausible thing to do and might undermine a lot of the efficiency benefits. Because if you destroy those real resources, that's an inefficiency cost. Yeah, go ahead, James.
No, I was just wondering that if I'm not going to be directly receiving the benefit according to exactly what I reported, is it not watered down enough by the fact that it's going to be sort of, the benefit will be, I'll be getting the average of this benefit that goes to everybody, to mean that it's not...
Yeah, but in that type of situation when there are a lot of people, your incentives to tell the truth might also be really, really small as well. So not so obvious that it works. Another big problem is collusion. So let's think about the example of the eminent domain case here, right? Imagine that in eminent domain, there were two people who really didn't want an assembly to take place. But they didn't want to pay all this money that would come from being the person who vetoed the assembly. What if they both reported that their land was worth $100 million to them, right? Then neither of them would be individually responsible for having vetoed the sale, right? And so neither of them would have to pay anything. So they can veto the sale without having to pay anything, which totally destroys the incentive properties, right? Or imagine there are two people who really did want the sale to go forward because they were going to get some money. Or they were shill bidders or something like that. They could say, oh, actually, I want to get rid of my land. I'm willing to pay a huge amount to get rid of my land. And then they could cause the assembly to go through without paying anything, right? Because neither of them individually are pivotal. So in fact, even though that's not only a collusive thing, that's actually an equilibrium. Because neither of them are paying anything. So they're just as happy to do that as they were to tell the truth. In fact, maybe happier, right? Much happier. So what that tells us is that even though there is a truthful equilibrium of VCG, there's also for any two individuals in one of these collective choice problems always an equilibrium where those two individuals get whatever they want at zero cost, which is not such a bad equilibrium for those two guys and a really bad problem for the VCG mechanism. In fact, if one person can pretend to be two people, they can do this, right? That's called the Demerger problem, right? So that means that in practice, even though while it has these nice theoretical properties, in practice, VCG is sort of a total disaster, right? So Mohammed, why intuitively do you think that VCG is sort of going so wrong? Why is it messing up so badly? What's the source of both of these problems?
That it depends on the second person's value, and like if you talk with him and he brings the value down, then you're playing.
Exactly. So the basic problem is that other people are being asked to say what your externalities are. So like, it's depending on this idea that you pay your externality. But it's other people that are telling what the externalities are. And that's fundamentally the problem. So that means that because they're only being incentivized to get the right outcome for them, not to report truthfully the externalities that you're causing, and yet the mechanism is using the externalities that you're causing to give you the right incentives, that gives you all sorts of reasons to monkey around with those other people to mess up how much you're paying. And it means that if you take any of those revenues and refund them to people, people are going to start lying to try to influence the externalities that it appears other people are paying, right? So what we need is either some objective information at some point down this line, right? Rather than just like basing everyone's externalities on what everybody else says their externalities are and so forth, we need to at some point have the externalities they pay be based on some more objective information. Or we need to in some way make people prove that others are actually exerting the externalities on them, right? And these are actually closely related to one another, right? So if one person is going to pay for saying that another person did wrong, then they need to know about what the other person might actually do, right? So that is, we need, in both of these cases, we need to bring something back to some sort of objective information. And one way to do this is to try to determine not what the actual externalities that you end up causing in a particular case are, but what they are on average. Now, unfortunately, a very pessimistic result from Jerry Green and Jean-Jacques Lafont says that this is impossible. So they say the only system where you always have an incentive to tell the truth regardless of what others say is the Vickrey-Clark-Groves mechanism, plus or minus some transfer to you, which depends on what other people say, but not on what you say. This is the only thing that makes the social and individual choices the same and makes them want to do it independent of the actions of everyone else. So this is VCG's great strength, but it's also its killer weakness, right?